Hello and welcome to another video from Line Parallelogram, and this time we're going to be looking at how you can use one of these infrared remotes with your Raspberry Pi. Now we're going to be creating a simple application that will respond to the coloured buttons on this remote I have here. So let's get started. Before we can get stuck in with obtaining the codes from these remotes, let me quickly explain the hardware that we're going to be using. Now, the centre of this project is one of these. It's a little infrared receiver mounted on a circuit board, and these come from eBay for just a couple of pennies. Next thing is obviously our Raspberry Pi. I'm using the B+3, so you can use any, but this is what I have been doing my tests with. Next, we have our remote, which is just a fairly generic, cheap one that came with one of these little light bulbs. Finally, you just need a couple of generic wires. Now, to connect it up, you'll want to find the correct pins on your board. On mine you can see there's a little S marked there. There we go. And you can also see a plus and minus. So if I'm going to quickly connect some appropriate coloured wires, we'll have green for S, blue for ground, and apparently purple for positive. So let's put that onto there. We can then connect the positive to the 3.3 volts of your Pi. Make sure to do the 3.3 volts because it's going to be the same voltage that is output on the signal pin. Then we're going to connect the ground to pin 9 and the signal out to pin 11. And just like that, we have our circuitry. So, very simple. Now, we're just going to do a jump cut over to the Raspberry Pi. Right about now. The Pi is now booted up and ready to go. But before we get into obtaining the codes, I thought it would be good to show you the waveform on the oscilloscope so I can explain how the protocol system works. Now, if we just switch over the application here, we should see that it's outputting approximately 3.3 volts. It's a little bit less, actually, but it's approximately there. So, now let's quickly enable a trigger, which will capture the moment that the pin goes low. Then we enable the trigger and press the button. I'm going to press the on button, and hopefully... Oh, it's stopped. Hang on. Now let's try again. There we go. So we can see this large pulse here, and then we can see this sequence of smaller pulses, which is actually the data. So we're going to zoom in a little bit. Let's scroll along, and we shall see this. So let's try and decode what this means. This remote uses a protocol known as the NEC protocol, and what that basically means is the two binary digits, so a logical 1 and a logical 0, are represented with two things. A logical 0 is represented by a pulse that is 562.5 microseconds, followed by a 562.5 microsecond gap. So that's half a millisecond. As you can see, that's pretty much what this is here. So this is probably going to be a 0. In fact, I'll just bring up my screen sketch. So let's circle this bit. Oh, that's amazing. And so this is a logical 0. A A logical 1 is a pulse of the same duration. So this pulse here, followed by a 187.5 microsecond gap. So that will be this one here. So let's circle that and label this as a 1. So if we do that for all of them, like this, we should be able to find out the code that our remote is emitting. But obviously this is incredibly labour intensive and not something we want to be doing. So let's jump back over to the Raspberry Pi and look at the code. Okay, let's jump into full screen mode quickly, and then we'll make a start. I would say the easiest way to obtain these codes will be to download a piece of software that I wrote especially for this purpose. The way you're going to do that is simply to open up a terminal window and type git clone https://github.com/lime-parallelogram/ir-code-decoder, and then 2 dashes .git, and hit enter. That will download a couple of files to your system. Let me show you those in the file browser. In this folder here, we can see a couple of things. First one is this folder, which just has a couple of icons in. You could ignore that. And then you have these 2 versions of the software. The first one is a graphical one that I spent ages on, and then there's a slightly more simple command line version. You can do whichever one you please. So, to open up the software, you can just do cd ir code decoder with 2 dashes, and then you can type Python, and I'm going to use the GUI version. That will give you a little prompt that looks like this for you to enter the pin that your receiver is connected to. Mine is connected to pin 11. This is the GPIO board system, by the way. And then it prompts you to enter a name for your remote. I'm going to call it color bulb because that is what this remote came from. Unfortunately, this input prompt does not support capitalization, but that's just because I had to make it from scratch. Now, to get the codes, we just want to click Start Test, and when it says Awaiting Data, just press the button on your remote, and a hex code will pop up. You can then click Save Command, and it will prompt you for a button name. I'm going to call it red, because that's the button I just pressed, and then hit return. Do it again, this time for the green button, and then again for the blue. I'm just going to make a couple more buttons on my file, and then I will get back. Right, I've now added 10 codes to the program, and the output of this program is a file. So if we go back to our file browser, open up the folder, and you'll see a file with the name of your remote as its name. So if you open that up, you'll see a list of all the buttons and their codes. So don't delete that or anything. We'll be coming back to that in just a few minutes. So let's close out all of this and we'll be ready to move on. Right, now moving on to the main part of this video, which is the programming. As always, the code will be available on GitHub, so if you prefer, you can just download it from there and modify it as you please. However, I am going to type it out here so I can explain in a bit more detail what bits do and help you understand what's going on. So let's open up our Genie editor. And first of all, make this file saved and in the Python format. So we go to Documents. Let's just call it ir.py and save it. Now we can get on with doing the first bit, which is importing the modules. So the first one we're going to need is rpi.gpio, and I always like to call it GPIO for simplicity. We're also going to need to import the datetime module. There we go. And now we're going to set up a few variables. So the first one being pin. So let's set my pin to pin 11. And also our buttons array. So in this, you're just going to need to open up your file that we made earlier. This one. In fact, I'm going to open it in Genie just for extra ease over here. And we can just copy in all of these values. So let's have this. There we go, that didn't take too long. So now we need to make a names array that we can use to cross-reference it. Now it's very important that you do this in the same order as you will see later. So we'll just call it buttons name, and then we can make this one an array too. And in here we just need to add a list of all of the button names, whatever you want to call them. So I'm just going to put the caps lock on, and let's do that now. There we go. That's now in place. If you're not making this list, I would highly recommend using a comment to do something similar, just to help you if you need to debug your code. Now we can move on to starting up the GPIO. So we need to do gpio.setMode, gpio.board, and then gpio.setup pin as gpio.in, all in caps. Now we can move on to the subroutine. So we'll do def, and we'll call it get binary. And in here, we're going to first of all set a few variables. First one is num1s, and this represents the amount of consecutive ones received from the sensor. We will later use this to determine when the command has finished. We also need a variable called binary, and we need to set this one to 1, as if you set it to 0, the multiplication will not work. Next, we need to create an empty array. So we call that command, and we just make it empty. And then we need to make another variable called previous value. It's very important you set this to 0 because when I was testing, I set it to 1 by accident and it skewed up the whole code. Then finally, you need to set value to GPIO dot input on the pin. Now we need to do a while value, and this will just wait until the pin goes low, signaling the command has started. And in here you can just write GPIO value equals GPIO dot get input, dot input on pin. Underneath that we can write start time, and we'll set this to datetime dot now and close those brackets. So now we can move on to the main while statement. So that will just be a while true. And in here we want to write if previous value is not equal, so exclamation mark equals value, then we need to record the current time in a variable called now. So do datetime dot now. Then under that we will do a variable called pulse time, and this will record the difference between now and start time. Then we can reset start time. We're doing start time equals now. And finally we can record this data in our command variable, doing command dot append to open brackets and putting in there previous value and then pulse time. And make sure to do pulse time dot microseconds. Always forget that one. Now, underneath this, we need to quickly do a thing that will increase our num1s variable up here. So we do if value, so that means if true, because 1 is equal to true in Python. Then we'll do num1s plus equals 1. Underneath that, we'll do else num1s equals 0, because it is the consecutive ones we should be recording. Underneath that, we can do if num1s is greater than 10,000, then we will break the loop. Finally, we need to update our value and previous value. So we'll do previous value equals value, and then set value to GPIO dot get, dot input. Always do that. And put pin in the bracket. Now we can jump out of this while loop here and begin to interpret the command as a binary value. To do that, we need to do for open brackets typ, which will stand for type, and tme, which will stand for time in command. And then we can do if typ equals 1. So if we are looking at a rest period, then we're going to look at the time. And if TME is greater than 1000, so if you remember earlier we were looking at the protocol, then we can safely assume that this is going to be a 1. So we'll do binary equals binary multiplied by 10 plus 1. So at the moment it'll be 1, we'll times it by 10 to make 10, and then we'll add 1 to make 11. else, we will assume it is a 0 because that's the only other option. Binary, and we can do simply times equals 10 to times it by 10. Now, underneath, during testing, I discovered that occasionally you would get 2 row characters on the end of your binary. So to fix this, we can do if the length of string binary is greater than 34, then binary equals the integer of the string binary, open square brackets, colon 34, which will just keep the first 34 characters, and close the brackets. Now, the last thing to do is to return our binary value, so we can do return binary and jump out of this subroutine. Now we need to make another much smaller subroutine called convert hex, and in there we want to get our binary. Let's just make it, call it binary value, and do a colon. In here we need to make a variable, just call it tmpb2, standing for temporary base 2, and we're going to set this to the integer conversion of the string of binary value, and then we'll convert this to base 2 with 2 on the end, and finally we will return the hexadecimal value of tmpb2. Underneath that, we can go into our main program area and make another while true loop. And in here, we can do a for loop. But first, we need to do in data equals convert hex get binary. We'll do these closed areas, and then we will close that bracket as well. Underneath that, we're going to do for button. Oops. In range, the length of button. So it's important that you do it in range the length, because we're not going to be using a straight up pull values system, because we need to get the reference. Now in here we can just do if button equals in data, then we're going to print buttons names button, and close that bracket. You also need to put a hexadecimal conversion on here for some reason. I don't really know why. Now, that should be it. Hopefully it will work. If we save it and click run, no errors to start with, that's good news. And let's press the red button, and there we go. So it's come up with the red value. Let's try green. Green, there we go. How about light green? Light green. Looks like it's working. That's really good news. So, as you can see, this is not really useful. However, using this simple lookup system, you can create all kinds of different types of code. Now, I hope you liked this video. It did take me a long time to make, as I've been through so many iterations of this code. However, we have finally got there to show you today. I hope it helped you. If it did, please leave a like down below, comment any other opinions, and subscribe for more content. Thanks for watching.